With the global warming crisis, wildfires are getting more common and more severe. This means that there are greater and greater demands on wildland firefighters, one of the most challenging jobs around. In today's episode, we'll take a look at the risks for heat injuries in wildland firefighters. Specifically, we'll examine whether and how different tasks that wildland firefighters have to perform affect their risk for hyperthermia and heat injuries. Wildfires are a natural part of the life cycle of nature, but global warming has sparked more frequent and destructive wildfires each summer. While a good amount of research has been done on urban firefighters, relatively less has been performed on wildland firefighters, which have quite different job demands that make it hard to simply extrapolate or transfer between the two types of jobs, except that both require working in very hot environments. Wildland firefighting is highly mobile and can last for days or weeks at a time. This also brings about potential sleep deprivation and also challenges with maintaining nutrition and hydration. Surprisingly, very little work has looked at the thermal stress of wildland firefighting and the risk for heat injuries. Those that exist have largely just looked at overall average temperatures over the course of a shift, without separating the impact of different actual tasks or how long they're performed for at any one time. This is important because knowing what tasks are the most thermally challenging would allow for better planning, prediction, and scheduling. To help with this, West and colleagues in 2020 tracked almost 300 wildland firefighters throughout a wide geographic range. Firefighters wore a heart rate monitor and ingested temperature pills to give real-time data throughout an entire shift. They also had observers following them who recorded what tasks they were performing every minute of the entire work shift. These 55 different tasks were then categorized by trained experts into 4 intensity categories. These ranged from sedentary ones such as briefings and rest breaks, through light and moderate ones, to high-intensity activities like hiking into the fire site and active and direct fire suppression. The researchers then took all of the data and calculated how each of the 4 intensities of task affected core temperature. This included controlling for individual characteristics such as age and fitness, and also for what type of task was done beforehand. This graph shows the change in core temperature on the vertical and time on the horizontal axis. The typical task lasted on average for 47 minutes, and if this was continuously done at high intensity, core temperature rose about 0.44 degrees Celsius. By itself, this isn't dangerous, but if this was extended outwards to the far right over 6 hours, temperature would rise to a potentially challenging 1.6 degrees Celsius. Moderate intensity exercise would result in 0.19 degrees Celsius rise after 47 minutes and 0.7 degrees Celsius after 6 hours. Light and sedentary work had negligible thermal impact. The main result that harder intensity tasks drive higher body temperatures isn't necessarily surprising by itself, but the main breakthrough from this study is to be really granular about the heat stress in wildland firefighters, and to parse out how different tasks affect the thermal risk. Categorizing these tasks into broad buckets of intensities can help with predicting the risks for heat injuries based on task and time spent doing them over one day or over multiple days. More importantly, this study drives the policy message of rotating between different intensity tasks to allow for thermal recovery, which must be kept top of mind for both firefighters and planners during the high stress of actual wildland firefighting. I hope that this video ignites your interest and knowledge about the extreme job of wildland firefighting. I'm Professor Stephen Chung, and I run the Environmental Ergonomics Lab at Brock University in Canada. We post new videos about different topics in environmental physiology every Wednesday. Thanks for watching. We'll see you next time.